All right, welcome back, fourth graders. So this begins kind of the second half of this chapter. We'll start with this week's lesson, 13.5, and you'll notice the title, Fractions and Decimals on a Number Line. So this is going back to a number line usage. And I've also included in this post teaching tool 14. You'll see that I've went ahead and numbered it already, but these are number lines, and if you remember correctly, they always start with 0. Just wanted to remind you that. But you can represent fractions on this number line as well, and I'll model that here. You can also represent decimals on this number line. Okay. So before we begin, I really wanted to clarify a few things, just to make sure you understand. So what does it mean for two fractions to be equivalent? And I want to draw your attention to the two that I drew at the bottom, 3/5 and 3/10. Are those equivalent? No. You probably see that the top, the numerators match, but not the bottoms, 5 and 10. They do not match. So what do you have to do in order to have equivalent fractions? So having equivalent fractions means this different fractions that name the same part. So it's using denominators to find it. So you probably see something that they have in common right away. You're looking at the 5, I guarantee it, and the 10, and you're thinking, okay, I can multiply this fraction by 2, both top and bottom, to get 10 on the bottom, so I have a like denominator, and I multiply this and I get 6. 6/10 is another name for 3/5. 6/10 is definitely bigger than 3/10, so they're not equivalent fractions at all. But that's how you could compare them. So let's get started on a number line. Okay. So just as a reminder, number lines, again, start with 0. So your number line, you could use your graph paper to make a beautiful number line. It comes out so nice. They always start with 0, and then every tick, these are called ticks, every tick will be 1, and it depends. I'm not going to add my fraction till I get to the end. See how many I get. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have 10. So really, I could represent this as a tenth. So 2/10, 3/10, 4/10. You get the idea. Keeping the total number of 10. So you know what happens when we get to 10 over 10, right? Sorry, it becomes a whole. So if we're talking about those two fractions again, let's just bring them back up. So I have, the first fraction we were talking about was 3/5, and the second fraction I was talking about was 3/10. So using a different color, to show you kind of where they are. So 3/10 on this number line is here. Okay? We can't use this tenth line with 3/5 until we actually change this. So let's find equivalent fractions so that we could use the tenths. So again, looking at the denominator, because that's the most important part. Can we get it to 10? Sure we can. So that means multiplying the top and bottom by the same number. In this case, it's going to be 2. Then we're going to multiply straight across. You guys are really good with multiplication. I watched that last week. So we have 6/10. So on this one, 6/10 is right here. So you can notice that obviously this is a much bigger fraction. So it's over 1/2, and half of this, you can see right here, 5 is half of 10, so it's over a half. Closer more now toward the whole. So I'm going to go ahead and kind of show you how a decimal works on this. So this is a fraction. A decimal works very much the same way. So decimals are going to be placed over a power of 10. And I just want to review with you again. We've got these places, place of value, and they go for every spot. There's an equal spot on this side. So in this case, I'm looking at the hundreds, the tens, and the ones. When we have the decimal point, this is a decimal point, it changes the meaning of the number. So no longer is it a whole number. For example, I have 1 marker. 1 marker. If I were to snap this marker in half, which I can't do, I would only have half a marker. And that would be represented over here. And I'm now knowing that these are going to be, this is the decimal part, we also call these fractions. These are parts of a whole. And they are fractions slash decimals. I guess I should turn the board like this. Okay, so they are one and the same. They're just, they look a little different. Half, as we know, fun little thing, if I broke this marker in half, I would have half of a marker. You know that's represented out of 2. Really kind of a fun thing. Well, over here, if I have half, it's not going to be 2. No, that will be said 2/10. 2/10 is not equal to 1/2. So I'm going to now take you to what it means. Let's take that number line we were just dealing with. Okay, I'll just blue number line this time. And I'm going to start with my 0. I always do. I'm not going to name it till I get to the end because I want to make sure I count them out right. And I'm just going to 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll extend this a little bit more because I want a 10. And I'll show you why. So these are fractions. You're right. You could go 1 over 10, 2 over 10, like we did. And when you get down here, it's 10 over 10. I want you to also know that these mean something. 1/10. So with our place value, so here's our whole number. There's no whole number in this, so I'm putting a 0. And there's going to be fractions. So this would be, if I put my little spot right here, that is called 1/10 because this is the 10th spot, remember? Now, to get even smaller, and I know it makes counterintuitive, this place is called the hundredths. In the hundredths place, notice my THS, my hundredths place is even smaller. So, you haven't figured it out, I'm now filming outside behind in the garage because it's like the only quiet place in the house. So, 1/10 would look like this, 0.1. If I were to take over here, that is 0.5. There we go. That's halfway, right? So another name for this one is 0.5, 5/10, or 1/2. And you can label it like this, 0.1, 0.2, 0.3, 0.4. Again, I want you to keep that 0 with it because that's saying that there's no whole number. In this case, we're just talking about a portion of it. 0.5, that's kind of that talk we got to. When we get over here, we're going to have, this is the hard part, 10 over 10. So let's go, oops, 0.5, 0.6, 0.7, 0.8, 0.9 is a fairly large fraction. When you get 2, you can't say 0.10 because that goes all the way back here again. It pushes you back to 1. When you get to 1 whole, guess what? It's represented as a decimal. 1.0. That's kind of cool, right? Because it's 1 whole. So you can say 10 over 10, 1 whole, or just 1. In the decimal speak, that's pretty easy. I forgot my 0 in front of all these, but because that doesn't mean they're still fractions. There's our number line. Now, one of the strangest things you're going to see today is actually a number line. And I'm going to do 5 because it's just a little easier. I'm going to go quick 1, 2, 3, 4, 5. Okay. I'm going to put a decimal in front of each one of these. So now I'm talking about, is that right? I think I did something. I did do something funky. I can't do 5s because I need power of 10. Oh, I'm glad you saw that mistake. So you're going to use, if we're talking about that teaching tool, I'll just show you again what I did. I went ahead and numbered them. You'll notice that there's some that go from 0 to 1 and then goes all the way to 0 to 16. So again, if you had 16 over 16, you get 1 whole. These mean a little something different when you're dealing with decimals. So stay with the powers of 10, and the powers of 10 are right here, working with 10, because you can also get 10s to 100 and 10s to 1,000, and that's the decimal system. Okay, I'm going to throw out a little example for you. Just a second here. Okay, so my number line, again, is going to go from, in your graph paper is perfect for this. It's going to go from 0 to 1 whole, and I'm going to make them 10 even. So just use your graph paper to make those ticks. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 when we get there. Okay. So we see that there's 10 equal parts in this whole thing. Now we're going to show how we can convert these to decimals. Well, I already did actually, didn't I? Well, let me just jump right into what it means to be a hundredths, because you're familiar with the tenths. Each one of these, if we just add that as a tenth. Hundredths is really tricky. Hundredths actually happens right in here. And you're gonna see this picture kind of blown out like this. For every 10, there's gonna be another 10. So it's gonna be ticked out like this. So you're gonna have to go 1, 2, 3, 4, 5, 6, 7, 8, 10. And I didn't quite make it evenly spaced, but there's a 10. So by the time you get there, you've got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It's kind of like when you look at a ruler, these are the really small parts in here. So that's what that means. And if I were to number them, this starts with 10. I just add a 0 to the end of it to make it the hundreds. And then it's gonna go, the next one will be 11, point 11, point 12, point 13, point 14, point 15, point 16, point 17, point 18, until you get to point 20. So another name for 2, and this is from last week's lesson, another name or equivalent fraction for this is 0.20. So that would be read differently. This is 2 tenths represented right here. There's our 2 tenths for 0.2. And we can say 20 hundredths, same thing, but you're gonna have to enlarge each and every section to see that what falls between here is 10 to 20, 20 to 30, 30 to 40. What's kind of cool when you get up on some of these, how does that work? So this is 0.6 and 0.7. What falls in there between, again, you have another little group of 10, all little 10s in here. You're gonna break this section out. It's gonna start from an equivalent fraction of 0.60, which another name for that is 0.6. And it's gonna go 61, 62, 63, 64, 65, all the way to 0.7D, another name for 0.7. So that's kind of your job today, looking at the number line and figuring out what it is they represented. If I were to give you one example very quickly from our guided practice, so let's go to GP. Okay. It says for 1 and 2, use the number line below to name the fraction. So the number line only has a few clues on it. So again, it starts with a 0, and this number line ends in a 1. Okay, and let's see if I can count it out right. Okay, let's see if I can. Did you get my guess? I was 8. So the first one, they have a letter A here. This is A. The next one is right here. Oops, right here, and it says letter B. And the next one, oops, I lied. This one says C. Then it goes over here. It goes B. Okay. And they want you to name these things on a number line. So number 1 says A. What does A equal? So the first thing I do is I always count. I go 1, 2, 3, 4, 5, 6, 7, 8. I purposely made it out of 8. Now if I'm talking about fractions, this is going to be, I should have put fractions down here because I have to draw something underneath it. This is going to be 1/8. I can do it sideways. 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then 8/8 is 1 whole. So we're good down here. Converting that also to decimals, ooh, that's tricky because they're not a 10. So they want to know what this is fractionally. So you say, okay, that is going to equal 1/8. They want to know for number 2. Number 2 says B. What is B? So go all the way down here. So you can see I wrote it down. Well, B is 7/8. Cool. That's what they want. And then they're going to play a little bit more with 3 through 4. And 3 through 4 has an enlarged graph like I showed you before. It might take me too much time. So this is 3 and 4. This is name the point on the number line for each decimal. So number 3 says 1.33. So this would be read 1 and decimal points. You always use the word and. 1 and 33. The last digit here takes its tag hundredths. So 1 and 33 hundredths. And they want you to locate this on a line. And the line they give you starts at 0 and it ends at 2. Kind of tricky. So there's a 1 and a 2 on this number line. And those are whole numbers, I think. Hold on, yes. And then they give you a halfway mark here. They say this is 0.5. They say this is 1.5. Oh, and here we go into something called a mixed number, and this is mixed number also. It's a fraction and a decimal point. So with that, they say find 1.33, and you have to use your knowledge of where it would fit. So 1.3 is already going to be over 1. If this is 1.5, I think that 1.3 is going to fall somewhere in here. That's what I'm thinking, right around here. So if it does say name the point on the number line, let's see if they have a point. They do have a point. They have right here, they have something called E, and over here they have H. I kind of gave it away. So H obviously would be 1.33, and number 4 they want you to know 1.39. Oh, that's tricky. Do they have another one on there? Oh, wow, they got even more detailed. So they blast out of here. It's so hard to draw these things, especially on a tiny board. But from H, they open it up like this. And there's another number line that kind of connects down here. I'm hoping that you can see it in your book, but I'll just tell you the answer. It is actually going to be G, and G is actually written down here. That's terrible. I know, you can't see it very well. So just remember that there are going to be using base 10. Use base 10 for sure. And I want you to use the ideas that decimals are represented over a 10th, a 100th, and that's when that number line explodes and is broken up into smaller pieces. So the tens is now broken up into tenths. I'll go to hundredths. And then of course that's where they stop you in 4th grade. All right, give it a whirl. Use the Learning Bridge at the top. And also really look at those examples of their number lines and how they break them down and explode. I call it explode out into the hundreds, to smaller parts. All right, you guys, hang in there. I'll talk to you tomorrow. Oh no. Oh dear.